Hi, let's take a look at reducing fractions to their lowest terms, and we're going to bring up something called the greatest common factor here. But first, let's look at a little rule here. Oops, I got a duck. Now here is a little rule we can go by. It says that we take two fractions represented by a over b and c over d. We can multiply the numerators together, the top numbers, and then the denominators together. And so, as an example, we could have 2/5 times 3/7, or we have 2/3 times 5/7. And so you just multiply the the numerators together and the denominators. Okay, let's use that rule, but we'll sort of use it backwards in order to reduce 4/14 to its lowest terms. So what we can do is we can take and divide 4 up into 2 times 2 and 14 to 2 times 7 and 2 times 2 over 2 times 7. Those fractions together multiply. 2 over 2 is just 1, and so we'll get 2 7s. So we're sort of using that. We're using that little rule that we had at the beginning. Now I'm going to show you two different ways of reducing fractions here. Got a duck again. And that's one way. Now, let's look at the greatest common factor represented by GCF. We're going to use something that, like what we did in the last lesson, prime factorization. So let's look at 12, and that's 2 squared times 3. And then let's look at 30. It's 2 times 3 times 5. Look for the lowest factors that they have in common with the smallest exponents. In this case, it's a 2 and a 3. Multiply those together, and that gives you 6. That is the largest number that will divide into both of those numbers. So now let's use that idea here. Let's set it up as a fraction, 12 over 30. So we can use that rule at the beginning. So we'll go 2 times 6. 6 is our greatest common factor. And 5 times 6. Separate that into two fractions. 2/5 times 6 over 6. 6 over 6 is just 1. And we land up with 2/5 as our reduced fraction from 12/30. So let's try that again. 24 and 28. Do a prime factorization of each one of those. So we got 2 cubed times 3. Now I'm going to fudge with that a little bit and make that 2 squared times 6. Both of those give you 24, and you'll see why here in a second here. Now 28 is 2 squared times 7. So we got two squares squared in each one of those. So we'll pull that out. That's our lowest factor that we have in common. So that's 2 squared, and that equals 4. So 4 is the largest number that we can divide evenly into 24 and 28. So let's set it up as a fraction and use that first rule that we went over, and we can have 6 times 4 over 7 times 4, and then we can pull those apart and have two fractions, have 6 sevenths times 4 fourths, and 4 fourths is just 1, and so we'll get 6 sevenths. So that's a way of reducing to the lowest terms using the greatest common factor. Oops, looks like we got Euclid coming here. Let's see what he's up to. It looks like he wants to drop something off here. All right, let's see. Yeah, he's going to do something. He's dropping off another problem for us. So it's 35 over 65. Let me duck. Now, since they both end in 5, let's divide through by 5. Let's divide both the numerator and denominator by 5. And that happens to be our greatest common factor, and we'll reduce to 7/13. So this is another way, more common way here of reducing to lowest terms. Ooh, here comes John Bernoulli. He's going to drop off a problem. 33 over 55. Got a duck. 33 over 55. Let's try 11 since they got sort of the same numbers on the top and the bottom. So we'll just divide, that'd be our greatest common factor, divide 11 into both the numerator and denominator, and we'll just get 3/5. Thank you.